Hey YouTube, I wanted to share my power cabinet project with you. It can control power to two feeds, so I can run this at 240 with each one of my power control units on a 120 line. And so I have these two units stacked in here. This would be for one phase of the 120. This would be for second phase of 120. I've got my amp and voltmeter for each line, and I have the switches that control power factor correction caps. So I'd like to show you those next. So these just pull out. You can use them individually or together, like I have in the power control cabinet. And each one of these segments is good for 2,500 watts, so I could control 5,000 watts with this power control cabinet. Alright, so this is a visual overview of the power control segment. Again, my amp and voltmeters, power outlet with the switches that control the power factor correction capacitors. I'll flip over here to the other side of the unit. So I have 6 power factor correction capacitors, and I'll show you how these are wired up with the schematic in a minute. So they all come in and interface to the switches, and all the switches interface to this bus bar, and lines feed the power in from the power line, connect and plug, and power goes through the meters into the capacitors and is available at the outlets here. So this is a schematic of the a single power control power factor correction unit. This here. So we have our 120 volts AC. We have our voltmeter across the line monitoring the voltage. We've got our amp meter, and current will flow through the amp meter into our bank of capacitors. And I have this arranged such that switch 1 controls one 60 microfarad capacitor, switch 2 controls two 60 microfarad capacitors, switch 3 controls three 60 microfarad capacitors, and between the combination of these 3 switches you can go from 1 to 6 capacitors in parallel, and then that would be in parallel with the load, which for my load today I'm going to show you is my neon sign transformer bank. Alright, so you should be able to see 3 things here. There will be the arc here. There'll be our amps, our current draw, our voltage, and you'll be able to see the volt amps on our kilowatt power meter. I'm going to be flipping the switches, which are just out of the camera's view. I'm going to flip 1, 2, and 3. 1600 VA, and we're going to apply our power factor correction capacitor. This is a 60 microfarad. And we've corrected by 300 VA. Now we're going to flick switch 2 and add additional capacitance to the circuit. And we're going to flick switch 3. So we brought our current down from initially 15 amps all the way down to 4 amps, and reduced our volt amps draw from 1600 to 490 VA. And now let's look at power factor. I'll flick the switches on. Right now we have a power factor of 0.84. I'm going to remove switch 3. It drops to a power factor of 0.48. I'm going to remove switch 2. Power factor drops to 0.28, and I'm going to remove my final capacitor. And without any capacitance, our power factor is 0.2, and our current draw is 15 amps. And it just slides back. And then I just plug it in, and those cords go to the variable transformer. And that's my power control power factor correction cabinet.